of last section and this section where we're going to be doing the linear factorizations now. So basically, we're going to be finding the possible zeros, then figuring out which ones are, and then basically writing it out in factors.
Okay.
So the problems officially say find all of the zeros and write a linear factorization of the function. So they give us f of x is equal to x cubed minus 10x squared plus 44x minus 69. So I need all possible zeros, so it's going to be plus or minus 69 over 1. So I'm just going to go ahead and write them all out. So what are the factors here?
Plus or minus 1.
3.
Plus, yeah, 3.
6.
Nope.
23.
Oh.
Why did you say 4, Virginia? It's an odd number.
Okay, I got confused.
Plus or minus.
Let's go with 69.
Yep.
Okay.
All right, so when you graph that, tell me which ones look like, or well, do y'all want to graph it, or do you want me to just tell you which one it's going to be? Are y'all okay with graphing and finding them? Okay. So how many factors should we end up having by the time this is all said and done? 3, right? Because it's a cubic function. So 3 is the only one that is going to be a real one, or like something that we can, yeah, it's going to be the only real one. So we're going to use synthetic to do that. So 3 up here in the corner. So we got 1, negative 10, 44, and negative 69. And don't forget, if there's ever a term missing, make sure you put in the 0. So bring down the 1, times 3 is 3, minus 10 is negative 7, times 3 is negative 21, plus 44 is 23, times 3 is 69, which gives us 0. So that means that x equals 3 is a 0, so x minus 3 is a factor. So when I write my linear factorization, this is going to be one of them. So I like to write it off to the side just so I already have it ready when I'm all said and done. So this was a cubed term here. So that means now this is squared. So x squared minus 7x plus 23. So at this point, I always want to see if I can factor it, but the only factors of 23 are 1 and 23. So I can't factor it. And so what I'm going to do now is the quadratic formula, because that's going to give me x equals, and it's going to give me 2 values because there's always a plus and minus. And then that will give us our factors. So these ones are going to look kind of weird. Sometimes they're a little nicer than that, but not in this situation. So, negative b, so it's going to end up being positive 7, plus or minus the square root of b squared, so it's going to be 49, minus 4 times 1 times 23, so that's going to be 80, 90, nope, wait, 92?
102, 92.
4 times 23?
102.
Should be 92.
Yeah, that.
All over 2a, so that's just going to be over 2. So I've got 7 plus or minus the square root of negative 43 over 2. So this negative in here, I have to do what with it? Make it an I. So this is going to be 7 plus or minus I root 43 over 2. And obviously if there's anything we could take out of the inside, we would, but there's nothing I can take out. So when I do my 2 factors, I'm going to have plus, I'm going to have basically this whole thing as a positive, and, or words. X equals this, okay? So when I move it over, it's going to be x minus this whole thing, but this sign is going to be positive in 1, and it's going to be negative in 1. But if you wanted to write it as like, if you wanted to do this, 7 over 2 plus or minus I root 43 over 2, you could also do that, but I would just leave it all together and write it. But more so just a notation if it ever comes up as a multiple choice question on an exam or on your exam. That would be the only reason. So this is going to be, I have x minus 3 as a factor. So x minus 3. This is x equals this. So I'm going to do the positive one first. So it's going to be x minus, and then this whole thing, 7 plus I root 43 over 2. And then x minus the negative 1, 7 minus I root 43 over 2. Okay, and remember that's because when we have the i's, if we have one, we've got to have the other. And so by doing the quadratic formula, that takes care of both of them for us. We just have to make sure we write them both times. So this whole thing would be our linear factorization. Make sure I do these in order. Okay, 34. These say use the given 0 to find all of the zeros and write a linear factorization. So it tells you what one of them is, and then we're going to have to go through and find the other ones. So 34, it says that 4i is a 0 of f of x is equal to x to the 4th plus 13x squared minus 48. So it already tells us that's a 0, but I'm going to need to reduce it down, obviously, to be able to get to the next ones. But I know that if 4i is a 0, what must also be true? Negative 4i must also be 1. So I'm going to use both of those to check, which will get me down to a squared function, which hopefully will be something that I can factor. And if it's not, then hopefully it'll be something that will be easy with a quadratic formula. So I'm going to start with positive 4i since that's the one they gave me. So I've got 1. Cubed term is missing, so I've got to put a 0. Squared term is 13. X term is missing, so I'm putting a 0. And then I've got negative 48. So these work the same way, even though there's an I in there. So this would be 1, 4i, which is 4i. So then I've got 4i times 4i, which is going to be 16i squared, which is also known as negative 16. So that's going to give me a negative 3 times 4i, which is going to be negative 12i, which I bring down because it's a 0. So then that's going to be negative 48i squared, which is also known as positive 48. And so that gives me 0. So I always start with that one because they tell me that that is a 0. So if you don't get 0 out at the end, something with your math is wrong. Okay. So then now I'm going to use these numbers with negative 4i. So I'm going to have negative 4i here. And then now this was an x to the 4th term. Now it's going to be an x cubed term, just for the sake of making sure I'm paying attention. So then I bring down, or 1, 4i, negative 3, and negative 12i. And then I go through the exact same process I just did. Bring down the 1. That's going to be negative 4i, which gives me 0. Times that is 0, which gives me negative 3. Times negative 4i would give me 12i, so plus 12i, which gives me, 12i minus 12i would be 0. So that also is a 0. Okay, now those were zeros, so that means that what was my factor for this one? If x equals 4i was a 0, then
X minus 4i.
minus 4i, so we got to move it over. Then this one would have been what?
X
Yep, x plus 4i. So those two I know I'll have. So now I'm left with, this was a cube term, so it's now squared. So x squared, there's no x term, minus 3. Set it equal to 0 and solve. So this one's nice. We can't factor, but I can move the 3 over and then take the square root. So x squared is equal to 3. So then take the square root of both sides. That gives me what?
Positive negative square root of 3.
Yep. So plus or minus the square root of 3. So that means that then I have factors of what?
X minus square root of 3, x plus square root of 3, x
Yep.
plus 4i, x minus 4i.
Yep. So then I write it all together, like you said, x minus 4i, and it doesn't matter the order, x plus 4i, x minus the square root of 3, x plus the square root of 3. All right, the next one, it's doing the same thing, but it says to write the function as a product of linear and irreducible quadratic factors with all real coefficients. So, anyways, we're just factoring it down as much as possible. But the difference in this one is they want everything to be real. So they do not want us to factor it down so much that we end up with things that are irrational or like whatever. So 42 f of x is equal to x to the 4th minus 2x cubed plus x squared minus 8x minus 12. So this one doesn't give us any zeros, so what do I need to do? So that's going to be plus or minus 12 over 1. So what are the factors of 12?
Plus or minus 1, minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12.
So again, I'm going to save you from having to type it in for the sake of time since y'all know how to do that. So the ones that I should check are going to be -1 and +3. So -1 and 3 are what's going to get checked. Doesn't matter which one is first, but I'll do -1 first. So -1, and then I'm not missing any terms, so everything will just be copied down. So 1, -2, 1, -8, -12. And then just follow through with synthetic. So 1 times -1 is -1, minus 2 is -3, times -1 is +3, plus 1 is 4, times -1 is -4. It's -12 times -1 is +12, minus 12 is 0. So -1 worked. So what is my factor? X plus 1. And then I'm going to try 3. And a lot of people like try to go back and use the original, but if you use the original, you're going to be miserable because it's not going to ever get down to something that's reduced. So make sure you always are using the reduced version. So this was a 4th term. It's now cubed. So 1 minus 3, 4, and -12. And then follow through with synthetic on this one. So 1 times 3 is 3, minus 3 is 0. Times 3 is 0, that's 4, times 3 is 12, -12, plus 12 is 0, so my factor is x minus 3, and so now this is a squared term, so I'm left with x squared plus 4. Can that be simplified down to something that is, what is the wording, irreducible quadratic factors with real coefficients? So can I simplify that down anymore? Because what's going to happen if I set that equal to 0 and solve?
You're going to get an I term.
Yep, I'm going to get i's, and they don't want that. They want everything to be real. So this is going to be my final factor, is x squared plus 4. So my linear factorization for this one is going to be x plus 1 times x minus 3 times x squared plus 4. And so if you get to something that's not factorable either, where you would have to use quadratic, you go ahead and stop there as well. They just want it as simple as possible without having anything that's irreducible or whatever. All right, I'm going to go ahead and tell you your problems, but like I said, you'll have all tomorrow, and if you feel like, because I know those were 3 different types of problem, but they're also all doing the same general thing. So if you feel like you need to see another one tomorrow, just let me know. You're welcome to start on it now if you want, but I need to get things together for leaving. So 1, 11, 15, 23, 29, 33, 37, and 41. Now for some reason I had a mark on 23. What is 23? Oh wait, we don't know how to scratch 23. We didn't do that. Stating how many zeros it has.
These are
Yes.
math.